Hey everyone, welcome to Sharanya Study Point. In today's class, let us solve exercise 4.3 of quadratic equation. So look at the first question. So here it says we'll have to again find out the discriminant of the given quadratic equation. And if, if the roots exist, if the real roots exist, you will have to further proceed and find the roots of the equation. So finding out the discriminant of this, b square minus 4ac, what do we get? We get minus 31. Getting the values of a, b, c from the equation and substituting here. So minus 3 the whole square, minus 4 into a is 2 here and c is 5. So therefore it is 9 minus 40. 9 minus 40 gives me minus 31. So therefore the discriminant is lesser than 0, right? So we already know if the discriminant is lesser than 0, okay, then there are no real roots that is going to exist. So therefore you have to conclude, since the discriminant is less than 0, no real roots exist for this equation. Let us solve the second question of the first main, exercise 4.3. Now it says 3x square minus 4 root 3x plus 4 equal to 0. So finding out the discriminant for this, okay. So we get, as usual, writing down the values of a, b, c, and then b square minus 4ac. So now here b square minus 4 root 3 the whole square, okay, minus 4 into a is 3 and c is 4. Now here the square belongs to minus 4 and also to root 3. So therefore minus 4 whole square is 16 into root 3 gives me 3. Minus 4 into 3 is 12, 12 4s are 48. So therefore 16 into 3 is 48. So 48 minus 48 equal to 0. Then you have to write the roots are therefore real and here equal, just because the discriminant is equal to 0. Now, if they are real and equal, then what are the roots? Okay. So now, using this formula and substituting the values of a, b, c here. So minus of minus 4 root 3 plus or minus, anyways you have found out b square minus 4ac to be 0. So therefore, I have just substituted the 0 here, divided by 2 into 3. 3 is the value of a. Okay. So therefore, x is equal to minus into minus is plus 4 root 3 and plus 0 divided by 6, or 4 root 3 minus 0, because it is plus or minus, right, divided by 6. So either way, when you add 0 or when you subtract 0, you are going to get 4 root 3. So x is equal to 4 root 3 upon 6. So 4 and 6 can be cancelled, 2 times and 2 3 times. So therefore we get x is equal to 2 root 3 upon 3. Then you have to conclude the roots of the given quadratic equation are 2 root 3 upon 3 and 2 root 3 upon 3. And the third problem of the first main, exercise 4.3. So here again finding out the discriminant, okay. So we get a, b, c values here. Substituting in the discriminant, what do we get? Minus 6 the whole square, okay, it is b square, minus 4 into a 2 and c is 3. So now minus 6 the whole square will be 36, minus 4 2s are 8, 8 3s are 24. So therefore 36 minus 24 gives me 12, and 12, yes, it is greater than 0. So if the discriminant is greater than 0, then the roots are real. So then if they are real, finding out what are the roots. So x is equal to minus of minus 6 plus or minus. Anyways, we have found out the discriminant to be 12. So substituting that here, divided by 2a, right? So 2 into a is 2 here. Okay. Now the next step, minus of minus is plus. So therefore 6 plus or minus. This root 12 can be written as 4 into 3. Correct? Upon 4. Now, this root belongs to root 4 as 3 as well, isn't it? So, what do? When I distribute the root to 4 and 3, so it can be written as, rewritten like this. So, therefore, x is equal to 6 plus or minus, root 4 is 2, okay, square root of 4 is 2 and root 3 as it is, divided by 4. So, further proceeding, x is equal to 6 plus 2 root 3 upon 4. Now, if you see in the numerator, 2 is common. So, when I take 2 out, 2 into 3 plus root 3, because 2 into 3 gives me 6 plus 2 into root 3 gives me 2 root 3 divided by 4. And here 6 minus, when I take 4 minus, it's minus 2 root 3 upon 4. And when I take 2 out common, 2 into 3 minus root 3 upon 4. So therefore, here 2 one time and 2 two times. Right? Now x is equal to 3 plus root 3 upon 2 and x is equal to 3 minus root 3 upon 2 are the roots of the given quadratic equation. Let's look at the first question and the second main. So here again 2x square plus kx plus 3 equal to 0. Okay. Now we have to find out the discriminant of this, and in the question it is already given that the discriminant is equal to 0, which means the roots are real and equal is what they have given. If when are the roots a real and equal? When the discriminant is equal to 0. So obviously what we can do, we can equate the discriminant is equal to 0. Now getting the values of a, b, c here from this equation, a is 2, right? B is k. Why it is k? Because the coefficient of x is k here and c is 3. So substituting a, b, c here, b square is k square minus 4 into a is 2 and c is 3 is equal to 0. Now k square minus 4 to 8, 8 3s are 24 equal to 0. So therefore k square is equal to 0 plus 24, isn't it? So therefore k is equal to plus or minus, k square is equal to 24. Then k is equal to plus or minus root 24. Now root 24 can be expressed as root of 4 into 6. Correct? Now this root belongs to 4 and 6. So when I distribute individually the roots, so I get k is equal to plus or minus 4 root 4 into root 6. Now root 4 is 2 and root 6 as it is. So therefore k is equal to plus root 6 or k is equal to minus root 6. Now look at the second question of the second main exercise 4.3. So kx into x minus 2 plus 6 is equal to 0. So now so far what we have seen, the given quadratic equations were in the standard form already, right? But here if you could see, it is not in the standard form. So what we have to do, we have to frame it into the standard form, meaning when I bring this kx inside the brackets, okay, when I multiply, it becomes kx into x is kx square minus as it is, and kx into 2 is 2kx plus 6 as it is equal to 0. So now if you could notice that it is in the form of standard quadratic equation ax square minus bx plus c equal to 0. Right? So now a value is k because coefficient of x square is k. Okay. B is equal to minus 2k. It is because the coefficient of x here is minus 2k. And C is the constant is 6. Right. Now substituting the values in b square minus 4ac is equal to 0. Why have we equated to 0? Because in the question it is already given that the discriminant are, I'm sorry, it is because in the question it is already given the roots are real and equal, right? So now substituting b is equal to minus 2k whole square minus 4 into a is k and c is 6 is equal to 0. So minus 2k the whole square gives me 4k square minus 4 into 6 is 24 and 24 into k, so 24k equal to 0. So now here if you could see 4k is common. Now taking out 4k we are remained with k minus 6 inside the bracket because 4k into k gives me 4k square minus 4k into 6 is 24k, right? So now when I equate 4k to 0 and k minus 6 is equal to 0, so what do we get? We get k is equal to 0 and k is equal to 6. Let us solve the third question under exercise 4.3. Now it says the length is twice the breadth. Okay, then I do not know the breadth. So I consider the breadth to be x meter. Then obviously the length will be twice the breadth, which means 2x meter. And in the question it is already given that the area of the length and breadth. Okay. When I multiply of the rectangle, I get 800 meters square. Right. So when I substitute area is equal to L into B. Okay. The rectangle area is L into B is equal to 800 meters square. So substituting L and B here, 2x into x is equal to 800 meters square. I get 2x square equal to 800 meters square. Then what will be x square? X square will be 800 upon 2 and meter square here. Okay. Along with the units I carry down in each and every step. Please do follow this. Now x square is equal to 400 meters square. Clear? Then what will be x? I need only x, right? So x is equal to the root of 400 meters square. and the root belongs to 400 as well as m square. So therefore distributing the root, so what do we get? X is equal to, this is 20, square root of 400 is 20, and square root of m square is m, because this square and this root get cancelled. So therefore x is equal to 20 meter, and what did we consider to be x? It is the breadth of that rectangle. So you'll have to write breadth is equal to x is equal to 20 meter and length is 2x, which is 40 meter. Then you can conclude the length and breadth of the rectangular mango groove are so and so respectively, and say that yes, it is possible for the mango groove to have this area and this dimension.
Exercise 4.3, fourth question. It is asking us if we can calculate the age of two friends, and when you take the sum of their ages, it is going to be 20. So let us consider the two friends to be A and B, or X and Y. As per your convenience, I'll take A and B. It says now A plus B is equal to 20 years. If one of the friends, say B, is X years old, then what will be the age of A? A will be obviously 20 minus X, right? Because sum of A and B is 20. Now, A plus B is equal to 20 years. A plus X is equal to 20 years. Then A will be equal to 20 minus X years old. And it also says that 4 years ago or before, say for example, if you are 20 years old now, your age 4 years ago would have been minus 4, right? So meaning 20 minus 4, which is equal to 16 years. So A's age will be 20 minus X minus 4, because currently A's age is 20, so minus 4 from that, which is equal to 16 minus X years. Then what will be the age of B? B's age 4 years ago will be X minus 4 years. In the question, it is given that product of the ages of A and B is 48. So, substituting the ages of A and B 4 years ago each, meaning 16 minus x into x minus 4 is equal to 48. So 16 first term into the second expression and the second term into the first expression, when you multiply, we get 16 into x is 16x minus 16 into minus 4 is 64 minus x into x is minus x square minus x into minus 4 is plus 4x equal to 48. Now shifting all the terms in my LHS to the RHS, what do we get? So minus 48, I'm sorry, 48 as it is, 16x becomes minus 16x, minus 64 becomes plus 64, minus x square becomes plus x square, and plus 4x becomes minus 4x is equal to 0. So therefore, what do you get? When you shift all the terms at the right hand side, you get 0. Now rearranging the terms and grouping the terms, what do we get? See, minus 16x and minus 4 are the like terms. And then we add these two constants, 48 plus 64. So therefore, what do we get? We get x square minus 20x minus 112 equal to 0. Now writing down the values of ABC from the quadratic equation that we have got, and substituting that in b square minus 4ac, we get minus 20 the whole square, which is b square minus 4 into 1 into c is 112, which is equal to 400 minus 448. Now if you could see, this b square minus 4ac is equal to minus 48, which is lesser than 0. So we can say that the roots are not real for this quadratic equation. So therefore the age cannot be determined for this. Let us solve the fifth question of exercise 4.3. So now it says the perimeter of a rectangle is 80 meter and the area of that rectangle is 400 meter square. So now we know what is the perimeter of a rectangle, isn't it? So 2 into L plus B is equal to 80 meter. Now then what is the area of a rectangle? It is L into B is equal to 400 meter square. So substituting that, we get this. So now here L plus B, or the sum of length and breadth, can be written as 80 upon 2, which is equal to 40 meter, right? So from this, when I get L,
Okay, when I extract L or the length from this, so length can be written as 40 minus B, which is equal to L. So therefore, mark this as first equation and this as the second equation. Okay, substituting this equation in this area formula, what do we get? So L into B is equal to 400, right? Now L is already 40 minus B. So substitute in place of L 40 minus B into B is equal to 400. Then B into 40 gives me 40B minus B into B is B square equal to 400. So now rearranging the terms, okay, and shifting all of them to one side, we get B square minus 40B plus 400 equal to 0. Now the factors of 400 will be minus 20 and minus 20 in such a way that the middle factor or the middle term is minus 40. Okay, so now here considering the first two, B is common, so B out, B minus 20, and here 20 is common, so minus 20 out and into B minus 20 equal to 0. So therefore B minus 20 and B minus 20 equal to 0 are the factors. Equating each of them to 0, we get B is equal to 20 meter. And what is B? It is the breadth. So if B is equal to 20 meter, then how can we find out the length? We can instead substitute L is equal to 40 minus B, right? So 40 minus 20 meter, which is equal to 20 meter. So for a rectangle, it is not possible for the length and breadth to be the same or to be of equal dimensions, right? If they are same, it is impossible for it to be a rectangle, but it can be called a square.